Okay, so here we are on to factoring lesson 2, which is working with a difference of two squares. And with this lesson, we want to factor polynomials completely by, well, this standard says that we're going to apply the polynomial identities, and we're going to ultimately factor a quadratic polynomial, and we're going to use a difference of two squares. So first we need to know what a perfect square is, and that would be a number that has a rational number as its square root. Where we could take a look, you see 36 is a perfect square because if you take the square root of 36, we would get the number 6. There are also other examples you may think of. Other perfect squares may be, for example, 49. If you take the square root of that, you get a whole number. The square root of that is 7. Or maybe 25. If you take the square root of 25, what do we get? 5. So these two are also examples. There are many others, but maybe a couple more might be 81 and let's say 64. Square root of 81 is 9, and the square root of 64 is 8. Okay. Now, I want to take a look at this first. What is the result of if we take x plus 3 times x minus 3? You will see that if we distribute here, we get x squared, x times x is x squared, x times minus 3 is minus 3x, 3 times x is plus 3x, and then 3 times minus 9 is, minus 3, that's minus 9. Now when we simplify, the 3x's cancel each other out, and we just are left with x squared, again the 3x's are gone, and minus 9. That's what we would come up with for that. That is actually a difference of two squares. And that's what we can notice. If we take the square root, if you recall from Unit 2, we had something, I'll just show you, something like 121 a to the 6th power b to the 4th. We simplified that. Remember, a coefficient can be simplified. So like 11, and then if we want to take the square root of any exponent, you just divide it by 2. So 11 a to the 3rd power, b to the 2nd power. Now that's one example, but let's apply this to if we want to look at like the square root of x squared. Well, the square root of x squared is x to the 1st, or just x. When we look at the square root of 9, the square root of 9 is 3. And here, if you look at the top, we have x plus 3 and x minus 3. That's going to be something that we'll return to when it comes to finding difference of two squares. So, if you look on the left, if you can identify what numbers like a squared minus b squared here, if you can figure out what a and b are, then you can set up your difference of squares. You're going to put your factors of a squared in the front part of each binomial, and for the factors of b squared, you'll put those factors in the back of each binomial. Now, something that I do get questions about. Students will say, well, what if you're adding between those? And the rule is you can't factor if it's like x squared plus 16 instead of x squared minus 16 up here. Because, well, as I said, it's not possible. You cannot factor, so you're not going to get any cases like that. Okay, well, let's take a look at number 3 here, problem 3. It says that we want to factor, and we want to find what the factored form of v squared minus 100 would be. So, if I think about, here, let me get back to my pen. V squared minus 100. The factors here, I'm going to set up 2 sets of parentheses. The factors of v squared, or if you take the square root, that would be v and v. Those factors go in the front. The square root of 100 is 10. So I'm going to put 10 in the back of each binomial. Now when we have this, the rule is in order to write our answer, you got to make sure you have a v minus 10 and then one has v plus 10. You change the signs, and that is a plus, not a times. So our answer, right away, we're already at the answer. It's v minus 10 times v plus 10. Okay, a couple things you want to look and consider. We want to make sure we ask ourselves, use this as a little bit of a checklist. First, do we only have 2 terms? That's absolutely crucial. Now also, aside from just 2 terms, are they perfect squares? If you were to take a radical and take the square root of those, would you get something, a whole value for those? Okay. Next, make sure that your variable has an even exponent. And finally, like I said a couple minutes ago, you must also be certain that you are subtracting between the 2 terms. You cannot add, otherwise you cannot factor. So, looking at focus question 1 here. X squared minus 4. Well, if we split this into 2 sets of parentheses, the factors of x squared, or if you take the square root, if you're looking at it that way. Either way, the factors of x squared go in front. That's just x times x. That gives you x squared. The factors of 4, or the square root, that's what we're really looking for. What is the root of 4? That would be 2. So we can put a 2 in the back of each binomial. And then just, again, make sure you have one which is x minus 2, and the other which is x plus 2. And we're done. Boom. Got that one completed. For number 2, we want to find the factors, or we need to factor 4n squared minus 16. So, I'm going to go ahead and set up my 2 sets of parentheses. Now when I look at this, 4n squared, don't forget about the coefficient or the variable. The root of 4n squared would be 2n. So I'm going to put 2n in the front of each part. Now, looking back at the 16, the factors of 16, if we're looking for the root, that would be 4. So I'll put 4's in both. And then again, I see that minus, so I'm going to put minus in front. It doesn't matter. You could put a minus or a plus in front. But if I put the minus in front, I must put a plus in the back. Just something to remember. When you take, when we FOIL, ultimately you want to see you're taking a negative times a positive. What would that ultimately come out as? A negative. So negative 4 times positive 4 should always give us negative 16. And that's one way we can look at that. Okay, so back to what we were saying. We have our answer, 2n minus 4 times 2n plus 4. Alright, we have, is this one, we have this and this. So, let's see, 2 more. With k squared minus 81, that is just a variable, so if I set up the parentheses, the root of k squared is k, so we'll put that in both. The square root of 81, that is 9, so put 9's in each. And then remember, we must put 1 minus and 1 plus. That's just my style. You could put the plus in front, and I did say that in the last example. But, again, your signs must be opposites to make it minus 81. Okay, last example. 36d squared minus 121. We need to factor that. So, when we factor, we have parentheses. We're going to fill each binomial. Now let's see what we could fill it with. 36, that's a perfect square. The square root is 6d. Now with 121, one way that you might be able to remember that, if you were to take the front and the back, sometimes we forget, what's the square root of 121? 11. They add up to the middle. 1 plus 1 is 2, and the outsides are just like the 11 that we were looking for. So we could put minus 11 and plus 11 in the place of that minus 121 when we're factoring. So we have 60 minus 11 times 60 plus 11. And we've reached the conclusion of another lesson. So good luck and factor on. See ya.